Shall we begin? Let's begin now. Let's begin now.
All right. Yeah, thank you. Oh, yeah, don't stand, don't speak. All right, thank you for hosting me. Very excited to be here. My name is Amir. I am CEO and Chief Parakeet at a small startup called Paracosm. Paracosm means imaginary world, like paranormal, cosmos, Paracosm, imaginary world. And it's actually a real word. And our logo is a space parakeet, parakeet cosmonaut, and he explores our imaginary world. But a lot of people ask about that. So, all right, so what we're all about is we are building software that's going to enable the next generation of machines to perceive the world. And you know, these include robots and tablets. And what's really exciting about it is that it has pretty deep implications for virtual and augmented reality. So we're going to show a whole bunch of fun demos. But I just want to take a minute to kind of point out, like, the enabling technology of all this are the upcoming generation of you know, spatially aware, depth sensing tablets that are going to be coming to market later this year, next year, and they're basically like, you know, if you're familiar with the Microsoft Kinect, it uses these infrared lasers to kind of, you know, beam a bunch of invisible dots into the room, and then the Kinect has like an infrared camera that can see it and use it to, you know, measure distance. And so what's really exciting is the next generation of tablets and phones are going to actually start to have these 3D depth sensing devices embedded in it. And some examples would be like the Google Project Tango, which, you know, if you come to the conference room after, if it hasn't run out of battery, you can play with it. The battery life kind of sucks. But, you know, and then, you know, Paracosm's big claim to fame is we were some of the original development partners on Project Tango. Very early on in Tango development, we worked on site with the ATAP team to develop some of the early 3D mapping code that runs on Tango. So that's kind of, you know, where we are today. And then, yeah, last kind of info on Paracosm. We're based in both Gainesville, Florida, and here in Cambridge. We're about 18 people. We're venture backed, and you know, that's enough about us. So, all right. So what we do is we take video from these depth sensing tablets, and what my coworker Effie here is holding is an early generation that has the phone embedded, and we have a cloud-based 3D reconstruction pipeline that takes every frame of 3D depth video from these tablets and stitches it together into a 3D model. So that's kind of our magic. We can build a virtual reality world of any space on Earth. And what's really exciting is pretty soon everyone's going to have a 3D sensing device in their pocket, on their phone, on your tablet. You know, you walk around a room, data gets uploaded, and you end up with 3D model. So that's kind of our secret sauce. You know, we have computer vision PhDs, computer graphics experts, and, you know, all sorts of software development expertise on our team, and we've developed all this software in-house. And so, yeah, let's just kind of enough talking. Let's look at some fun examples here. So, let's see if this works. All right, so let's open up with the most fun example. You know, Venture Cafe always has a ton of people walking around, so our software is not advanced enough to deal with people. But yesterday I was able to sneak into that back corner there. And so you can kind of see, you know, we have this whole back wall. I don't know how well this will show up, but we have it in full 3D. We'll turn on our 3D sensing. And what's cool is, you know, it looks a little rough because, you know, glass walls are invisible to these depth sensing, but we're able to capture the full structure of the room here. And if you look, we have, you know, you got like the banister, the same banister there, and it's all, you know, I could take tape measurements off of this. You know, it's all like dimensionally accurate. You know, if I pull up a tape measure and, you know, you measure it in real life, you know, it's going to be 3.8 meters in real life. So, you know, that's kind of our, you know, you can even see here, we got the, you know, you get the trash cans, and you get, you know, whatever that weird bar thing is back there. We can even hop over here, and you even get like, yeah, even get the, even get like a little fire extinguisher in that corner. So that's kind of the power of, you know, that's kind of the power of these devices, is we have a complete understanding of our environment, and the magic of this is that we can, well, let's look at some more fun demos first. There, you know, we have some more, play around with some more examples. You know, let's open this one. So here's my friend's house, and we did a 3D model of his house when it was under renovation. And so what's pretty revolutionary about this is we grab a tablet, walk through his house for 15 minutes, upload it. You know, it takes a little while for our processing to take effect, and then bam, we spit out like a full 3D model of a space here. And you can see, you know, you can see all the equipment, and, you know, the drywall is still being put up and everything. And what's cool is like we can drop it into like our favorite video game engine. Everyone here probably uses Unity or Unreal, and now that it's in Unreal, we can have like this crazy little like video game. I'm playing it with one hand. Maybe we can, you know, walk around my friend's house. We can like walk up the stairs. If I can do this one-handed, hold on. You know, we can. There you go. You know, and then. See all sorts of, and then so you know, you can also see things like you know, you can see all sorts of weird color artifacts. So, you know, all this data is generated by our software and the cameras on the device. So, you know, you can also see like, you know, adding color into a virtual reality model from a scan is actually a very, very difficult problem. We're still solving it. We've been working on it since day one. So we've been working on this about 2 years, and it's still a massively huge computational problem, because, you know, a lot of what we perceive in the real world is our brain playing tricks on us. You know, color and perception is, you know, really all filtered by our minds. But when you actually point a video camera at a scene, what it's really seeing is all sorts of, you know, light reflections and, you know, weird colors. And so when we go to reconstruct and color our models, we get all sorts of these crazy artifacts that you see. But, you know, we can let's see, some more fun examples here. We have an apartment, you know, right near our office that we use for testing a lot. And so you can see, again, you know, just from walking around and grabbing a video, processing it, you know, we can walk through doors, and you know, there's even, you know, a hallway. So this is, you know, this is kind of a revolution in how we can capture and document spaces in 3D. And, you know, you compare it to other types of, like, last VR meetup, there was someone who was like showed some demos of 3D food scanning. So like current state, yeah, there we go. And so like current state-of-the-art scanning is all, you know, they use techniques like called like photogrammetry, or, you know, and popular, if you're into 3D scanning, you might have heard of Microsoft Kinect Fusion. And so all these techniques that are around today are kind of focused on scanning individual objects or small tabletop scenes. And, you know, the way they kind of work is, you know, you have either a camera or Microsoft Kinect even looking at maybe it's a plate of food, or a tabletop, and as we move in a circle around it, your software can piece together a model. And it's able to do this because the computer memory can keep the whole object in memory at one time. It can keep building on top of it. But when you scan a room, none of that holds true, because if I'm pointing my camera at this half of the room, when I walk over to that half of the room, there's no connection between those two halves. So you can't hold the thing in memory. Your computer doesn't have enough memory. You would need like a gazillion gigabytes. Doesn't exist yet. And so you need an entirely new type of software algorithm to do this. And for people who are really into the nitty gritty, I don't know. It's called the class of algorithm is called a SLAM algorithm, and it stands for simultaneous localization and mapping, and it's very common in robotics applications. And basically, what we're doing is we're constantly logging data, 3D data and color data from this camera, keeping track of everything. And then you saw the jigsaw animation earlier, and then once we've kind of tracked all the data, our software builds a jigsaw puzzle out of all the pieces. We do it in the cloud across multiple machines, and we end up with the model you see here. And then the other interesting thing to note is, because we have to have an entire room modeled with a computer's memory, we sort of have to also spread the level of detail evenly around the room. So you'll also see, like, we try to do clever things like cluster the whoops, wrong button. But we try to cluster the mesh around areas of detail. You can see objects of interest try to have more density, and so we try to be able to preserve detail even in very large areas. So what's cool, and our big aha moment, let's see, I can show some more. I'll show one more quick demo just for fun. Let's see. Where is it? And here we go. So this is one of our early adopters, and they scan their house, and so you can see they have we're able to again handle multiple rooms, which is a very difficult problem. Like the walls reconstruct straight. We're still working on getting photorealistic. It's still it's still a little blurry for the reasons I told you before. And in order to deal with like color, it's sort of a trade-off. You can either get really sharp photo texture, or we can turn it into a watercolor painting and get rid of the weird effects. So we're trying to, there's definitely techniques to get the best of both worlds, but we're still working on it all. And so what's cool again, we can drop this 3D model right into Unity, and now, just like magic, we are, bam, in a virtual world. And it's not just any virtual world, it's this person's house with all your furniture. I can, one day as our software improves, I'll be able to, read the, see the pictures on the wall, and you can see like the teddy bear on the chair. We can walk into their kitchen and maybe look at their dirty dishes, refrigerator. And so, so this is like this alone is kind of really a cool concept, because we can capture with a handheld tablet, we can do a full survey, capture a space in full 3D, full dimensions. And what's really exciting is, as these tablets become pervasive, we're going to start to be able to build a database of every single place on Earth. And this alone is, okay, this is really cool, but you don't get venture backing just for doing cool stuff. The big aha moment of Paracosm, kind of the reason we exist, is not to just build these 3D models, but the realization is this is a representation of physical reality, right? So if we probably already X'd it out, but if we pull up our let's see here. If I open up recent projects, open project, So if we open up here, you know, our venture lab, right where everyone's standing on the rail here, you know, if we see like this, you know, this virtual reality model matches up perfectly to that section of the room right there. So this is a one-to-one representation of physical reality in virtual form. And what's really exciting about that is they sit right on top of each other. And the reason that's cool is because now we can do things like let this become sort of like, we think of it as like a Rosetta Stone. We can use our virtual reality maps as a translation link to allow robots to digest. You know, robots don't understand reality, but they understand bits. A robot can now digest this map, and you scan your living room, and now you can tell your, you know, robo vacuum cleaner, hey, you know, go vacuum this part of the house, and your robot can use it to navigate your house. And you know, we're actually iRobot's first corporate venture investment, and you know, maybe one day this will come to a vacuum cleaner near you. And and so you know, we talked about all this stuff, but you know, we put together like a, you know, so just kind of to illustrate it, just for fun, our marketing team did a papercraft project where they built a really cool, you know, fake lunar surface, and we decided to just make a fun little demo, just a few seconds long, to just show like, hey, you know, let's build a what happened to my here? There you go. So we built a little papercraft demo and 3D scanned it, and now, you know, that we have a fake little moonscape, you know, we put a camera on the robot, and now we have a little robot that can see, it recognizes what it's looking at, it can match it up to the moonscape, and now the robot, if we have a top-down view of the action coming up here, the robot can actually see where it is, you know, and it, you know, this is the robot's vision, and the robot has full, you know, it's almost like radar view in a video game. And this is not possible now, right? Right now, a robot in the space has no way to know where it is without a map, you know? It can keep from bumping in the walls, but it doesn't have a map of the environment. And that's kind of the magic of Paracosm. In fact, you know, if you remember our little model of this apartment here, now that we have a full virtual model of this apartment, we can also apply the same principle to a tablet. And now, when the tablet's camera is in this room, and we have a virtual map of the room, we can now align physical and virtual reality to start to break the bounds from virtual reality to sort of like augmented blended reality games. So, you know, exact same principle, but now we can run around the house and you can chase, you know, you can chase Nyan Cat through your house. And so, yeah, and so, you know, imagine kids playing Kidditch with Harry Potter or building Lego fortresses together. And again, what's happening is underneath this Nyan Cat is the skeleton of, you know, this 3D, let's see, do we have it? Yeah, so you can see it's this 3D skeleton that underpins the Nyan Cat. So really what's going on is another explainer video here. What's going on is we have, again, I'll pull up the same apartment. Yeah, I got a lot of material here. We've been doing this a long time. So, you know, we can now take virtual objects, drop them in our apartment, and you can see King Kong's actually living in the virtual world, but we just sort of hide the virtual world, and now we have a fully immersive, aware, you know, video game happening in our apartment, and the objects persist, and now the velociraptor is chasing me, and there's another King Kong behind the wall, fully occluded. We're working on adding multiplayer and drop shadows to be, you know, to jive with the actual lighting and virtual lighting effects. But you can see, like, you know, it's kind of unprecedented to have virtual objects actually live in our physical space side by side. So this is what kind of Paracosm is really about. You know, we can even, you know, this is, we use a little bit of fakery here, but we take the same 3D scan of the house. Eventually we'll be able to do this automated, But for right now, we manually segmented out individual objects, added some fancy graphics to impress investors, and then start to make games where physical interaction with your house becomes a thing. And now, just made like a little musical game for fun. Yeah. So yeah, it's just kind of. We're also, we play a lot of instruments in our company, so our lead engineer, one of our lead engineers actually wrote that song too. Cool. So, what else we got here? Yeah, but that's, we can have more fun demos too. I can also show some secret stuff we're working on in the future. I have some more cool algorithm visualizations. I don't know what people are interested in. We have 30 minutes, a long time. But I can take questions. I can show more demos or answer. Dive into technical detail.
Toward the end of your questions, we should be setting up his computer.
Okay.
But you've got a good 5-10 minutes. So,
okay. Yeah.
And tell them where you're set up.
Yeah, and I'll set up. We're gonna take a few of these models that you see here. We've imported into the Google Tango here, and what's kind of fun is I have a Dive headset, so you head mount the Tango and you can walk around the room, and it's a pretty amazing experience. Like the graphics quality is nowhere near any of these other demos. Like these things are mobile, low power devices, so the fidelity is pretty weak, but the experience of actually walking around a virtual space, especially when you can tell the space is based in reality, it's pretty surreal. It's very much a teleportation type experience. Maybe not like quite as fantastical, but it's pretty fun. So we'll have it set up in there. These things get like 15 minutes of battery, so we might have to do a lot of charging in between. Yeah, I'll take any questions.
You gave up?
We're clearing the chairs out of there, so you have a little.
Are you going to use audio on this?
Awesome. But it's so interesting.
Yeah.
Because it's big. That's pretty cool. So if I back up more, I'll just back away from it.
Yeah. Yeah, so the Dive is the headset, and it's holding the Google Tango tablet.
It's designed for the Tango?
This particular headset is, yes.
Wow.
So they specifically made Dive, I think. My name is Amir Rubin. I'm co-founder and CEO, chief parakeet of Paracosm. And we take video from next generation spatially aware mobile devices such as the Google Tango here, Intel RealSense, and we stitch the video together to create virtual reality models of indoor spaces. So the fancy term for that is 3D reconstruction. And we're a team of computer vision PhDs, computer graphics experts, 3D developers, game designers, software engineers, and we develop our own software, and it's pretty awesome.
So, are there any other companies out there that have similar technology to yours?
So there are companies in the space. It's a very hot space, and there's some really awesome startups working on this alongside of us. Everyone's taking their own sort of unique approach. So for example, there's a classic approach that is called photogrammetry that works fabulously well for scanning an object or building, like if you have a GoPro on UAV and you can scan around an object. Techniques like photogrammetry give you very nice 3D models. There's startups who do a very nice job scanning single objects or tabletop objects. There's startups that do a very nice job for other types of applications. But what makes us kind of unique is that we allow you to take a handheld tablet, walk around a room, upload it to the cloud, and we generate a 3D model of the entire room. And that's a very different problem, and it's really hard to process it all on a tablet. So our secret sauce is we have a very complicated 3D reconstruction algorithm in the cloud. We upload, you walk around the room very naturally. You don't need any special equipment except your 3D sensing tablet, and we build this 3D model of your living room, of your office, of museums and retail stores, and eventually every place on Earth 3Dified.
So who do you think is going to be really excited about this technology?
So right now, of course, it's VR and AR enthusiasts and roboticists, but the applications are going to be game-changing. So the robotics community, we want to serve them by using these 3D maps these 3D models as a map for the robot to navigate the space. For augmented reality users, we want to be able to use this 3D model as a basis to have really deep, immersive augmented reality games. And of course, for virtual reality, we are making virtual reality worlds, which is pretty awesome in and of itself. So those are the first three communities that we see this applying to, and then the applications kind of go off from there. We see a world where you'll have your own virtual personal shopping assistant walk you through a store, or visually impaired people walking into a 3D map building can receive audible instructions to navigate a building. So the power of 3D scanning and mapping that's going to be in everyone's pockets over the coming years is world-changing.
Wow, that is so exciting. Now, I would like to know, where is your company located? How can people find you?
So we got our start in Gainesville, Florida. Many of us are University of Florida graduates. And recently we moved to Cambridge, and I'm based here in Kendall Square. And we're backed by iRobot and Atlas Ventures and some other awesome investors, but those are our Boston folks. And we are working on building out our Cambridge office.
So those backers, did they pursue you? Did you pursue them? How did you get? These are big companies.
Yeah. That's a good question. We've got really lucky with amazing introductions. We were introduced to Atlas and Osage and Bold Start and Deep Fork through just amazing people I know in Florida, and they made the connection for me up here in Boston and Philadelphia and New York, San Francisco, and so I've been lucky to have great intros.
And plus, when they saw your software, I mean, they just knew they had to be a part of this awesome thing, right?
Yeah, it's pretty magic when you scan a room and then you can revisit it with virtually with a headset or something. It's nothing quite like it.
So is there any final words that you would like to say to the audience that you probably didn't say during the presentation?
Oh man, yeah, I think the spatially aware computing, 3D depth sensing is going to change the world. We're here to provide human understanding of the world to machines. It's like giving the same perception a human has, we're bringing to robots and software. So that is fundamentally different. Even when you go to your friend's house and you know where the bathroom is, that's because you have a perception of your friend's house. We're going to give that same understanding to your vacuum cleaner, to your tablet, and to your gaming systems. So pretty excited about it.
One thing that was really awesome during your presentation is how after you do the scan, you can upload it to a video game engine and kind of play in your own environment. That was awesome!
Yeah. So when you scan your living room, you scan your house, you and your friends scan it, that can be that 3D model is not just a virtual reality model that you can have as a video game level in your favorite game engine, but we can use it as the skeleton for an augmented reality game, so that you can, maybe one day you can chase your favorite, you can chase Mickey Mouse or, Harry Potter flying around your house or something, and you can build Lego fortresses and Minecraft worlds in your living room with your friends. So the 3D model provides the skeleton structure to, place virtual games into the real world, and you can, blended reality experiences.
Oh, that is awesome. Well, thank you so much for talking to us and giving us some one-on-one time.
Oh, yeah.
And great presentation, by the way.
Thank you.
All right. Check you later.
Awesome.